Good afternoon and namaskar to all of you. A lot has been said, and we all know about the importance of communication in our personal and professional life. Communication skill is one of the most important traits of a human being for his or her success, and the educational institutes across the world have at least one course or program dealing with communication. We all know the content of that course. We the engineers, electronics engineers in particular, focus on different aspects of communication. That is how fast and accurately we transmit our ideas through different mediums. We as common men understand 2G, 3G, 4G, and we all know how difficult our life would be without these G's. We, the residents of Jaipur city, though are waiting for 5G signal in our smartphones and computers, the people around the world are talking of beyond 5G. This lecture is about some technical aspect of this 5G. Professor A.K. Chaturvedi, speaker of the day, Professor Padi, Director MNIT, my faculty colleagues, staff and dear students. A warm welcome to you all to this lecture on non-orthogonal multiple access for 5G and beyond communication. You must be looking at different title, but meaning I think is the same as this title was communicated to Professor Chaturvedi in the morning. Till then, I had actually mailed this to you. So we started the journey of Institute lectures with the inaugural lecture by Professor Ashutosh Sharma, former Secretary DST. The second lecture was delivered by Professor Tirol, Nobel laureate. Then we had a lecture by Professor S.S. Murthy. We are here today for the fourth lecture of the series on non-orthogonal multiple access for 5G and beyond communication. And we are privileged to have Professor A.K. Chaturvedi as the speaker. To start with, I would like to request Professor Padi to please welcome Professor Chaturvedi with a floral bouquet. Thank you, sir. We, the teachers and students, are devotee of Ma Saraswati. Then why not we start today's program by lighting a lamp to please Ma Saraswati. For the same, I would request Professor Chaturvedi and Director sir to please come on this stage and lighten the lamp.
Jensa bhai
Yes, ready.
Very good afternoon to all of you. It's a wonderful moment. I'm a bit nervous to welcome Professor Chaturvedi, who happened to be my mentor at IIT. And first of all, Professor Chaturvedi is a very wonderful gentleman. Very rarely you come across people and you feel like remembering as and when an opportunity is available. So thank you very much to be here today. And when I requested him, I had been to Kanpur, IIT Kanpur on an official visit. And then when I entered to his office, we discovered that I happened to be the first guest to his office after he left IIT Roorkee and went to Kanpur. So it's a coincidence without any plan. When you love someone, actually you meet also frequently. And we are very fortunate that Professor Chaturvedi could get some time and he's here. And I'm very confident and sure the way we had actually guests from actually DST Secretary, Professor Sarma, then we have Tirole from France, and then we had actually SS Murthy, and probably will be the fourth Institute lecture series. And we all are privileged to be a part of this event today evening. And that's all from my side. I will not take a lot of time. Let's give time to Professor Chaturvedi on stage. Thank you, sir. Please come.
Thank you, sir. Before the lecture, I would like to formally introduce Professor Chaturvedi to you. In fact, I feel honored to introduce him to you. Professor Chaturvedi received his BTech, MTech, PhD degrees in electrical engineering from IIT Kanpur. He has served as head of the Department of Electrical Engineering, Dean of Research and Development, and Deputy Director at IIT Kanpur. He was the Sanjay and Rachna Pradhan Chair Professor at IIT Kanpur before moving to IIT Roorkee as its director. He has also served as the Director of IIAS Shimla and Director of IIT Mandi as well. He was also the coordinator of BSNL IITK Telecom Center of Excellence. Professor Chaturvedi is a recipient of INSA Teachers Award, Distinguished Teacher Award of IIT Kanpur, and Tan Chin Tuan Fellowship of NT Singapore. He is a founding member of the Telecom Standards Development Society of India, that is TSDSI, and has been a member of the Department of Telecommunication Committee, which recommended the criteria for spectrum allocation to telecom operators in 2008. His research interests are in communication theory and wireless communication. Now let us invite Professor Chaturvedi to deliver his lecture and enlighten us on the topic.
Hello. Yeah. Good evening, everyone. It's a great honor and privilege that MNIT community led by Professor Padi has given me, where I can see that you all have assembled here to learn more about 5G and related aspects, in particular about non-orthogonal multiple access. I have tried to slightly focus the topic in a manner so that at least 80 to 90% of the audience goes back with something that he or she remembers. It may be only 2 minutes of the talk, it may be only 5 minutes of the talk, but the attempt is that everybody who is given his or her valuable time to be present here for the next 40-45 minutes to 1 hour, he or she gets something to take back. Of course, if you are a student of wireless communication, if you are a student of 5G, maybe you will appreciate almost the entire talk or understand the entire talk. If you are not familiar with that, I will understand if you cannot relate to everything. But that is the challenge of giving a talk to an institute audience, because you try to customize it to as many people as possible, but probably it may be difficult to customize for everybody. So there is this outline that I have prepared for the talk. So first slide is about wireless communication trends. It is a very useful chart that has appeared recently in a journal. Maybe some of you may be interested, I can share with you after the talk. After that, I will talk about something that will be relevant even if you are not an electronics engineer, if you are a mechanical engineer, civil engineer, for everybody. I will want to discuss something that is relevant to especially wireless communication and other aspects. Then I want to briefly talk about what is this standardization process, 2G, 3G, 4G. I mean, why we do it, how we do it. And then I want to talk about a couple of slides on what are the key parameters that define 5G and how are they related to, say, 4G, and what is the direction to take for 6G. I have one slide on the role of information theory, because I believe or I feel that this very important topic often does not get adequate attention in many departments across the globe. And if you want to become a key student of any 4G, 5G, 6G, a good insight into information theory is indispensable. Without a good insight into information theory, these things become difficult to absorb. But once you have it, you sail through rather easily. And then I take up NOMA, that is non-orthogonal multiple axis. It will be about 6-7 slides on that. Overall, only 20 slides. Sit back and relax. Hopefully, you'll get something. So I wish we could have made this functional, but maybe this Mac issue. But that projector and this projector both are there. Should we shift the podium slightly this side? So if you cannot see this side, I hope you'll be able to see that side. Right? So this important, this is the chart that I was mentioning at the beginning of my talk. It very beautifully captures what is happening in terms of the evolution of data rates in the entire wireless domain. And as you know, the wireless domain is basically of two components. One is what we say as Wi-Fi, right? That usually laptop and things like that of that category. And the other is what we carry when we are traveling. It is something like outdoors, that is like cellular. Of course, cellular works inside also, but Wi-Fi doesn't work outside. What is the basic difference between Wi-Fi and cellular? Any student would like to say that the moment you talk about Wi-Fi and cellular, any student here would like to say? So Wi-Fi is in the unlicensed band. Cellular is in the licensed band. That makes a huge amount of difference in the way it is conceived, in the way it is standardized, in the way it is implemented. And you can see that because Wi-Fi does not have huge requirements of mobility, you are stationary or you are moving at a very low speed, because the distances are very small, right? So it is not a surprise that the Wi-Fi data rates have always been ahead of the cellular data rates, right? But as you can see that with the passage of time, the gap between the two trends is decreasing, and the hope is that by something like 2030 or beyond about 2035, we might see that the cellular rates are as good as the Wi-Fi rates. That is the projection, of course. How far it will turn out to be true, only time will tell. And if you see on the lower blue curve, we have started from GSM, GPRS, then Edge, then 3G, then 3.5G, then LTE, standing for 4G, then LTE advanced version of 4G, then 5G P1, the first version of 5G, release 16, then 5G P3, next version, and this is how it is going. And on the wireless LAN, if you see, it is like 802.11b, AG, N, AC, AD, AX, AY, all these things. And what is it that fundamentally changes in these versions? The physical layer. Physical layer is essentially the heart, just like there is a heart in the human body that has a rate at which it pumps the blood, and that rate decides the rate, for example, how fast we can walk, how fast we can run. There is a limit. Humans cannot run like a cheetah, or they cannot run like a bullet train. I think from where the fundamental limitations are coming. There are many limitations, but fundamental limitation is coming at the rate at which energy can be supplied to the muscles. So these are fundamental constraints. Similarly, physical layer is the fundamental constraint deciding the capacity or capability of a wireless communication device. So all these 802.11b, AG, they will all have a different physical layer, and depending on the band in which you are operating, the availability of bandwidth will change accordingly, and they will have made ports of operation. And as you know that as you go on moving up this chain, at some stage MIMO also it was introduced in Wi-Fi communication or the wireless LAN. So now this is happening through a massive collaboration at the global level. It couldn't have happened unless the research community, the government body, the United Nations, the IEEE, the industry body, all these bodies put their head and minds together because otherwise this kind of massive collaboration is infeasible, impossible. So the way these Gs are going, it is a tribute to the global community that it is able to come up with mechanisms which facilitate the standardization process. So this is what this slide, one slide is on standardization process. The body that is driving this evolution, after 3G, at the stage of 3G there were two bodies, one is known as 3GPP and the other is known as 3GPP2. PP stands for Partnership Project, so third generation partnership project. After that they said that we will not change the name of the body, so that name of the body has remained unchanged. It is still known as 3GPP, third generation partnership project. And this body carries forward the standardization process, and now it is working on already 6G. So basically there are multiple releases, each release defines a version, and whenever new release comes out, it is not necessarily a new G, but when it brings out a massive modification in the physical layer that the entire chain has to change, then a new generation is given, because the chipset, the hardware, the front end, the RAM, radio access network, everything has to change. So 3GPP does these 4 steps. First step is define the requirements for the next generation. What kind of spectral efficiency you need, what kind of data rates you need, what kind of density of mobile devices is required, what kind of data rates will be required when you are mobile, what kind of data rates will be required when you are stationary. So all these key requirements, and for these key requirements there is a consensus building exercise where international bodies request national bodies to submit their requirements, their expectations. After these requirements are there, then this entire body puts its minds together to come up with an architecture which can implement or which can deliver the requirements. And once there is some consensus on the architecture, then it goes on to draw the detailed specifications for the architecture, so that it is able to carry forward the job that has been assigned to it. And once the detailed specifications are ready, then we go for testing and validation for the entire standard. So this process is now very well sort of understood and very well appreciated. It is usually dominated by the industry. And the reason is not very difficult why it is dominated by the industry, because ultimately it is the industry that puts its money. Ideas can come from any direction, from any side, but finally somebody has to invest huge amounts of money to be able to invest in the new infrastructure, to be able to do the manufacturing, to be able to do the rollout. So these bodies are dominated by the industry, and I'm very happy that in the last few years, now Indian academia has also entered the standardization process, and there is a consortium of 6 IITs that gets its representatives into these bodies, and they are also making proposals, so that, for example, even in 5G some standards, some kind of specifications will be coming from the India group, and hopefully the role of India will increase with the passage of time. If you see the wireless LAN, it is not surprising to see that, maybe you have already noticed it, that those are IEEE standards. While if you see in cellular, those are not IEEE standards. And the reason is clearly what I said in the beginning, because that is the unlicensed band. So there the role of IEEE is there, but once deep pockets are involved, once the spectrum auction and spectrum bidding is required, at that stage it is not a simple exercise, and so the IEEE standards are not there. In fact, this body 3GPP is a body which starts with something called ITU, International Telecommunication Union, deciding the requirements, and then these bodies which consist of SDOs of member countries. SDO stands for Standards Development Organization, and each country has a SDO. Like when my biography was read, TSDSI was mentioned. TSDSI is Telecom Standards Development Society of India, and that body was formed a few years back. It has been given the status of an SDO for India, in addition to what the government bodies were doing, and that is why it is able to send its representatives on the international bodies and play a role there. So, I think I need to talk about the promise that I had made, that something that will be relevant to everyone. That is, what is the unique trait of an engineer? So if a student would, a couple of students would try to respond to this, I'll be very happy. If some response gets, I would not request the faculty. What is the unique trait of an engineer? The unique, that means it is something that others don't do, but the engineer can do, or engineers do. Many things engineers do that are common with non-engineers. So anybody? Yeah. That is true for NIT and IT students. Not for engineers. Am I right, teachers? See, teachers agree with me. Any other attempt? So many of us are very happy to say that engineers build things, engineers implement things, engineers can show that things work, engineers demonstrate practical things, engineers do hands-on things, right? All these things. But I don't believe these are unique traits of an engineer. There is something else which is unique to an engineer. What is that something else? I've given one hint. Engineers are, yeah, please, go ahead, yeah, very good. One more volunteer.
Which makes the human life easier.
Yeah, these are general things. Can we get more specific? Human life easier, I think doctors also, politicians also do. they give us many benefits. Okay, so yeah, please one more. Yeah, go ahead.
Delivery, the pregnant professor's daughter is pregnant, and that time there was no.
Achha, that is you are saying innovation in that sense.
Yes.
Okay. No, fine. Let me say what I have in mind or what I want to drive home often. See, what happens is that we miss out something very, very intrinsic to an engineer by talking about that hands-on, practical experiment, demonstration, something working, pilot study. All these things are important. This is not to say that these are not important. Engineer is the only guy who can actually, using pen and paper, tell you which direction to take for a product. Using computer simulations, using pen and paper, the engineer can guide us that which is the direction to take if you want to multiply the data rate by 100. And which are the directions which will be unproductive. Don't go in that direction. Because engineer has theoretical knowledge. Theoretical knowledge is the distinguishing feature, unique trait of an engineer. Of any product, of any technology, the fundamental engineering model, why so much theory is taught in engineering education is because that gives you a lifelong asset. And that is how engineers design. All these G's are all designed. Implementation comes much later. If you have to implement everything and try it out, you will never be able to do these things. And this is true even for a civil engineer, even for a mechanical engineer. You don't first build a bridge and then see whether it is working or not. You have to do a very detailed design, test that design using simulations, using civil structural engineering theory, using the theory of materials. Once you are convinced that this approach can work, only then you go for a pilot or for an implementation. So this unique attribute that you are able to conceptualize, you are able to create theoretical models, you are able to find answers to the direction to take, what directions to avoid, do the validation, initial validation on pen and paper or using MATLAB and or some simulations. This is what is the distinguishing feature of engineer. Even non-engineers build things, manufacture things, many of these things. Even a technician does it, but a technician is not equipped with that model. So this is a very good example of how society has progressed because engineers have the theoretical knowledge. Okay, now this is a more concrete slide, which is a triangle. And this triangle is showing three important use cases which define the 5G. the three vertices are the three important use cases. At the top, if you see, it says enhanced mobile broadband. So the requirement was that, okay, we have a 4G phone, we have a 3G phone, it is delivering data at some rate, it is giving us some user experience, we are able to do some kind of a website, we are able to do some elementary things, but we need much more enhancement in that. So enhanced mobile broadband, for example, hotspots. We should be able to manage hotspots. For example, in terms of peak data rates, we should get much more data rates so that we are able to manipulate much more intricate software than we are able to do. We are able to do the entries on the portals, do website manipulation, dynamic website manipulation, all these things. So this was defined in terms of, if you see, gigabits in a second, 3D video, UHD screens, ultra high density screens, work and play in the cloud, all this on the mobile phone. That is why this one vertex was called enhanced mobile broadband. Second vertex is at the second corner down on the right hand side. It is known as ultra reliable and low latency communication. Ultra reliable means that you cannot afford to go wrong. On the other hand, when you are downloading, you don't know in the background many mistakes are made, and then there are automatic repeat requests, download happens again, it aborted, all these things happen. Right? But it says no, there is a set of use cases where you cannot afford to go wrong, and at the same time the latency, that means the response time, has to be within a very, very short period. And what is that? The example are industry automation. So one big change that has happened with 5G is industry automation. We have moved on from thinking only about mobile phones, and we have gone on how we can increase the productivity of industry, whether it is mechanical industry, whether it is metallurgy industry, whether it is electronics industry, whether it is power industry, any industry. Self-driving cars. How we can improve vehicle-to-vehicle communication. That is why latency becomes important, and that is why reliability has to become ultra reliable. And the third user case was massive machine type communication. So the word massive and machine type both need to be understood here. Machine type means that 5G has visualized that a lot of it will be used by non-humans, machines. Forget the industry. Yes, in industry also a lot of machines will use it. Even in the home, a lot of machines will use it. Sensors, Internet of Things. All these massive, and these are not necessarily industry environments, these are all non-industry environments. They could be in a medical environment, they could be in an educational institution, they could be in our homes, they could be in our offices. So the idea was that you need massive, that means the number of devices which will want to connect to 5G will be multifold. Because earlier only mobile phones were expected to connect. Now these machines will also be expected to connect. So that is why it is called massive. And machine type normally means is that these will be less hungry for data rate. They will not ask for video downloads, they will not ask for website, dynamic website monitoring or web manipulation. They will ask for small things. They will either download some data file of few kilobytes, or they will send, upload some data file of few kilobytes, because these are not hungry for data. So massive machine type communication. So this is what is a very beautiful diagram that captures the use cases for 5G as has been visualized. And this figure builds on the previous triangle, and it defines 8 key capabilities or 8 key parameters of 5G. Each of the vertices that you see in this polygon, each vertex defines a key performance or key parameter requirement of 5G, known as key capabilities of 5G. So it says peak data rates, 20 gigabits per second. It says user experience data rate 100 megabits per second. Spectrum efficiency, it says 3 times 1x 3x. So what is 3x? So 3x of the previous generation. That means 3 times the spectrum efficiency as achieved by 4G. Then it takes mobility. Now it is talking about 500 kilometers per hour. And in fact 6G is talking about 1000 kilometers per hour mobility. That means even if the device is moving at that speed, maybe it's an aeroplane which is moving or anything that's moving, it should be possible to be able to do that. Of course 6G is still under discussion. But this is like 5G. Latency, 5G says 1 millisecond latency. That means the response time for these massive machine type devices should be 1 millisecond. If it sends a request, in 1 millisecond it should get it back. Connection density, 10 to the power 6 devices per square kilometer. So you can assume 1 million devices can be plugged in 1 square kilometer. If you look at only mobile communication, the number will be much smaller. Because this connection density is because of the reason, because we want to evolve massive machine type communication. Network efficiency 100 times that of 4G. And area traffic capacity 10 megabits per second per meter square. So average per meter square, the traffic density will be 10 megabits. Because there is a geographical dimension to cellular communication, that is why we often have to talk in terms of per square meter or per square kilometer. On an average, in 1 per square meter, this is the kind of data rate density or the traffic density that the network should be capable of. Once these specs are laid down, it is the job of the designers how to design the heart. What will be the coding algorithm? What will be the modulation rate? What kind of power levels that we have to think of? We cannot think of power rates which are infeasible. We cannot think of decoding strategies or algorithms that will take too long a time. So that is the fascination, that is the joy of studying physical layer communication. That means you have to get to grapple with some of the most difficult questions and you get to see answers by having a deeper knowledge of information theory or modulation theory. This slide I will not discuss in too detail, but here there are 3 colors basically. I will not repeat it. But here the introduction is of 3 colors. Enhanced mobile broadband is that's in green color, massive machine type communication in blue color, and the yellow color is for ultra reliable and low latency communication. It is showing 3 concentric circles, low, medium and high importance. So depending on which use case we are talking about, that use case, which attribute is more important to it. For example, when you are talking about ultra reliable and low latency communication, you are not too worried about peak data rate. Because it is not worried about gigabits and all that. Right? The key is low latency there. Right? And when you are talking about massive machine type communication, the key thing is connection density. That is the most important thing. Network energy efficiency, area traffic, of course, those are the similar parameters as before. So these 3 figures, they have been taken from one of the books on 5G, and they beautifully capture what is the definition, what is the defining features of 5G, what are the expectations from 5G. And I would like to clarify one thing, that whether it is 4G, 3G, 2G, 5G, all these Gs, they don't get implemented overnight. Right? For example, even in India, you might have heard that a launch was done in few select cities of 5G. That doesn't mean that the entire 5G has rolled out. Right? It only means that the infrastructure is in place, and with the passage of time, more and more features can get rolled out. The expectation is that in 5 years' time, maybe about 50% of users will be using 5G. 5 years later, it is still not today. So it is not necessary that every user has to use every feature or will be required to use. Some users will be required to use, some will not be required to use. There will be differentiation in terms of pricing. Maybe some of these will coexist, so that it should be possible to cater to different user segments depending on how much they can pay and how much they need for it. So none of these happens overnight. And one interesting thing that some of you may be familiar with is that India started with 2G. And because India started with 2G, something interesting happened, that in the first world, many of the advanced countries, including the United States of America, when 2G was launched in India, large parts in the United States were still on 1G. 1G is AMPS, Advanced Mobile Phone Service, that was an analog standard. 2G was the first digital standard, the very basic digital standard, what is commonly known as GSM and IS-95 CDMA. And why was India ahead of US? Nothing to do with any intrinsic technology issue. It is because we never had 1G. So we could go to 2G directly. Because they had made investments in 1G. Now, unless they extract the benefits of 1G, they would not like to deploy 2G. So these are all business cases or business scenarios, making investments return, and we, of course, we enjoy studying these things, but when you look at the marketplace, the dynamics are not necessarily driven purely by technology or theory. And this table defines more than 8 parameters. In fact, there are about 13 parameters that complete the definition for 5G: peak data rate, peak spectral efficiency, user space data rate, that you have seen. 5th percentile user spectral efficiency. Average spectral efficiency, area traffic capacity, user plane latency, control plane latency, connection density, energy efficiency, related to 2 aspects for enhanced mobile broadband, efficient data transmission in a loaded case, and low energy consumption when there are no data. So if you are not careful in drawing these specifications, you might end up in a problem down the line. If the requirements are too futuristic, no physical layer will be available for it. Or even if a physical layer is available for it, devices cannot be manufactured for it. Remember that down the chain, finally you have to do VLSI integration. You have to make sure that the processors, CPUs are available. You have to make sure that the clock speeds and the processing speeds and the bits that can be done, all that can cater to it. Then there is reliability, mobility, and mobility, interruption time, and bandwidth. So the purpose of giving this slide was to tell you that the number of parameters that define the 5G are much more than what we commonly talk about. Okay. Now I had mentioned in the beginning the role of theory or the role of modeling and why engineers can do the design. So in the case of communication engineers, that theoretical foundation or the underpinnings are often provided by information theory. And I will give you some concrete examples without getting distracted from the talk at hand, that how these G's have been greatly influenced by the progress in information theory. You remember turbo codes? Students, faculty, some of you may remember turbo codes, right? They were one of the important backbones for 3G. Without using turbo codes, 3G may not have become a reality. Turbo codes came in about 1992 kind of frame. They were the first codes where it was demonstrated that whatever was predicted as channel capacity by Shannon can actually be achieved. Of course, it was a simulation based on a methodology of specific decoding algorithm that showed that it is, and there was a way of constructing the channel code. So unless we had that okay, now you want to achieve this kind of reliability or this kind of efficiency, okay, use that code. Next was MIMO. Again, from where did we get the insight for MIMO? Again, information theory. It was shown that the way to increase capacity of a wireless channel is by deploying MIMO. It was shown theoretically, it was shown using information theory that it can increase the capacity of the channel, and the number of rate at which the capacity can increase depends upon the minimum of M1, M2. M1 and M2 are the input number of antennas and the output number of antennas. And imagine today all these Gs from 3G, 4G, 5G, 6, none of these Gs can function without MIMO, including the Wi-Fi. So it provides the basic direction by which it is possible to enhance the capacity of the channel, and because the capacity of the channel, now higher data rate can be designed. If you do not increase the capacity of the channel, no matter which physical layer you design, you will never be able to achieve the required data rate. That is what is the importance of theoretical insight. Unless you increase the capacity, unless you, it is like something like this. If the road is narrow, how can you expect the traffic to be very high? And you have to have a wide enough road to provide a high traffic. Same example. Capacity of the communication channel is the fundamental design on which all of these things are built. LDPs and polar codes, 5G. 5G has used polar codes and LDPC codes. Without those codes, again, very difficult to imagine. Polar codes for control plane, LDPC codes for the data plane. Because for polar codes, more reliability can exist for short block links. And that is what is required for low latency. That is what is required for these control channels. They need to get information quickly, and they cannot afford to send a long block length, unlike LDPC codes. And this brings us to the second half of the talk. We are now maybe almost 60% talk is done. Brings us to NOMA. NOMA is non-orthogonal multiple access. Now all engineering disciplines, whether you go to aerospace engineering, whether you go to mechanical engineering, whether you go to civil engineering, whether you go to electrical engineering, whether you go to electronics engineering, orthogonality is something very intrinsic. Because you need it to solve equations, you need to create models which are feasible, which are amenable to manipulation, all these things. So non-orthogonality is something which is counterintuitive, or which is more complex, which is difficult to handle, right? And the direction for NOMA, that is non-orthogonal multiple access, was again provided by information theory. I don't think we have a blackboard here, otherwise I would have drawn a quick cut, but let me tell you orally only. That using information theory, it can be shown that the capacity provided by non-orthogonal multiple access is higher than the capacity provided by orthogonal multiple access. So if there are two users, say user 1 and user 2, and they are trying to communicate in a common channel using a common resource with say rate R1 and rate R2, then the total data rate is R1 plus R2. Right? Because there are two users, one is sending at rate R1, the other is sending at rate R2, they are using a common resource, R1 plus R2. So this R1 plus R2 is more if you allow non-orthogonal multiple access. But if you don't allow non-orthogonal multiple access, then it is strictly lower. And that is why it was explored. Of course, it was shown using superposition coding. This is a coding method which relies on successive interference cancellation, that it is better than orthogonal multiple access. So let us try and understand what is this, because it's a very rich topic for research. Of course, in standards, it has been discussed for various different use cases. In which form it will come, how it will come, that is a matter of time. It is a common situation where the base station is sending signals to k different mobile stations. So it is from a common base station, a same signal is emanating, and that same signal is going to k users, from the first user to the kth user. And each user will extract from it whatever is relevant to it. So it is known as a one-to-many communication. On the right hand side, it is what is known as uplink, right? Left hand side is the downlink, that means from the base station to the mobile station to the base station, that is uplink. So all the users, 1 to k users, they are all sending their own data to a common base station, and this common base station has to make sense out of the signal that is coming from k users. So because this resource, they are sending over a common air interface. That means the air interface over these signals are traveling is common. So how do they coexist without interfering with each other? If two people start talking at the same time in this room, it will be very difficult to understand for either one. Who is saying what? Same thing happens here. One base station is sending its signal for k different users. Each mobile station will get confused. So this is the classical problem for what is known as multiple access. So this is the traditional way when for the first time radios were introduced, which send only audio signals, and when more than one radio station were designed. At that time itself, this FDMA was conceived. That means if you want two radio stations, I'm talking of 1930s and 40s, to transmit at the same time, and they should be available in the same geographical area, the only way to avoid their interference is give them different bands. So that is what is this FDMA, frequency division multiple access. When 2G came, 2G was one of the first popular standards which said, okay, we can also use TDMA. Because it was digital, so it did not require continuous connection between the base station and the mobile station. So it said that, okay, over one frequency band, we will accommodate multiple users, but make sure that they don't interfere with each other by giving them distinct time slots. So both these conventional multiple access schemes rely on the fact that they will somehow avoid interference. They will not allow more than one user in the same time. They will not allow more than one user in the same frequency if they are sending the same time. This is what is known as orthogonal multiple access. Of course, there is a third version of it. The third version of it is what is known as code division multiple access, or CDMA, where we try to use orthogonal codes. That means they will send in the same time, same band, but make sure that their spreading codes are orthogonal, or at least random enough so that the interference is low. That it can still be functional for all the users. So those are the traditional ways of ensuring usage of multiple resources for multiple users. NOVA is entirely different. NOVA is saying no. We are going to give the same resource at the same time in the same frequency using the same code more than one user. And why we are trying to complicate our life? One motivation, of course there are multiple motivations. One motivation is because it has shown the way that channel capacity can be increased. That is one important motivation. Okay. So now we quickly come to examples of NOMA. We focus when the NOMA principle is applied to a single orthogonal resource block. So when we say single orthogonal resource block means one frequency band in one given time slot, that is one of the blocks. And we say orthogonal because we are saying some other users can be in some other frequency band in some other time slot. And those of you who are familiar with multi-carrier, so it will be like one subcarrier. In one subcarrier, more than one user are there. This resource block may represent a single OFDMA subcarrier, a time slot, etc. So we take examples, concrete examples of two different forms of non-orthogonal multiple access. First form is what is known as power domain NOMA. This is the more common version, and in some form it will almost surely find presence in 6G. And the other is what is known as cognitive radio inspired NOMA. So let us try and create an example situation, and from that example situation it should be possible to understand mechanics of what is power domain NOMA, how it works, why it works, and why it gives a higher capacity compared to orthogonal multiple access. So here I have drawn a figure, and in this figure you can see that there is a base station. There are two users, user 1 and user 2, U1 and U2. And if you see the red color, that red color is U1, that is having power. It is showing the power level of user 1, and U2 is showing the power level of user 2, the blue color. So that means why it is showing red color is larger in height compared to blue color, because what is happening is that the red color is the power meant for the user that is far off. U1 is far off compared to U2. So U1 has a poorer channel compared to U2. Because U1 has a poorer channel, so it is trying to give it more power so that there is some sense of fairness between the two. The closer one will give less power, the farther one will be larger power. Now it is saying is that what we can do is, what will happen at user 1? Now at user 1 what will happen is, it will also receive the signal of user 2, and unfortunately it is receiving in the same time, same frequency, it is going to interfere. So it will be like the noise term. Signal plus noise. So now we have one more interference term. So what it will do is that user 1 is going to treat user 2 signal as noise. In other words, because user 2 signal is being treated as noise, the signal to noise ratio of user 1 will come down. If the signal to noise ratio for orthogonal multiple access was 10 dB, now it will be like 3 dB, 4 dB, because the effective noise has increased. What is the implication of this? Anybody? If the SNR comes down from say y to x and y is bigger than x, what's the implication? The capacity comes down. But the capacity is not zero. So earlier if it was able to say 10 megabits per second, maybe now it will be 1 megabit per second. This is the crux. By encountering interference and by increasing the noise available, that means you are reducing the signal to noise ratio, but that does not mean that meaningful communication cannot happen. It only means that the data rate will come down. So meaningful communication for U1 will happen, but what about U2? What about U2? Here what will happen is, it says decoding of U1 signal by treating U2 signal as noise. So user 2, which is closer, that will also decode user 1 signal. Because it has a larger power, it will be able to decode it, some data rate, and once it has decoded the user 1 signal, it will subtract it out. Once you know the interference, you subtract it out, interference is gone. So now user 2, what will happen is, it will be able to decode its own signal. I will show this using equations now. All users served at the same time frequency, users with better channel conditions get less power, that is the closer user gets less power, and successive interference cancellation is used. That means that once I have decoded the signal of the other user, I will subtract it out. Now here some of you may be worried, oh, what will happen to my privacy? Somebody else is decoding my signal. No, this is physical layer decoding. This is not the information decoding which is encrypted or which is data protected by many other keys. So your privacy or secrecy is not at all compromised in this manner. It only makes the job of the receiver bit complicated. That is the price you have to pay. So now let us see the equation. Okay, I will show the complete slide here so that you can quickly go. So for the example shown in the previous figure, we denote the message to the user I by say Si, that means S1 and S2. Its channel by H1 and H2 Hi, and its power elevation coefficient by alpha I. And we assume that mod of H1 is less than equal to mod H2 because user 1 is far off, so the channel gain is less, right? So that is why mod H1 is less than equal to H2, which means alpha 1, that is the power given to user 1 is more. Alpha 1 is greater than alpha 2. Now what does the base station send? it sends the superimposed signal alpha 1 S1 plus alpha 2 S2 because it is sending a composite signal in the same time band in the same time slot. User I that observes Yi, that is Hi multiplied by this, because user I multiplies the received signal by its corresponding channel. So the corresponding channel is Hi, H1 or H2. User I decodes its message directly with the following way. So now you look at the equation that log 2. Do you recall what from you have seen that equation multiple times? The classical capacity equation for an interval channel. Now we don't use it otherwise, but when you are designing the direction to take, this is the equation that is the bread and butter. So look at the log 2 1 plus mod h1 square upon alpha 1 square divided by, this is the kind of rate that is achievable by user 1. And after SIT, user 2's rate is given by log 2 1 plus rho h2 alpha 2 square. Why does it say after SIC? Because after successive interference cancellation, user 1 is removed. Once user 1 is removed, so now user 2's rate is directly 1 plus rho mod h2 square into alpha 2 square. Now both the users have positive, non-zero rates. One user has to pay a price in terms of a more complicated receiver because it has to do SIC, successive interference cancellation. And SIC is a technique that was known 40-50 years back in information theory. Time has come to use it. Hence log 2 is less than or equal to this, and based on this we can see that now we'll show in this slide, this is the important slide of today's talk, where we show that the non-orthogonal multiple access can achieve over orthogonal multiple access. Let me complete the slide so that I don't have to come here this time. Okay. So recall with normal, user 1's rate is given by this and user 2's rate is given by this. Now assume that now we want to compare orthogonal multiple access with non-orthogonal multiple access. So we take one extreme case, we claim an extreme case where a high SNR scenario, that is rho tending to infinity, and rho h1 tending to 0 because h1 is a poor channel, which implies that user 1 channel experiences a deep weight, and we get this expression for some rate, that is log 2. And if the two log terms, if you just multiply their corresponding arguments, you will get a simple equation log 2 rho h2 square. When it is compared with the orthogonal multiple access, I need an answer from you. Why both the terms have been multiplied by half? When I am trying to compare with the orthogonal multiple access, you notice that both the terms have been multiplied by half. Because they are doing resource sharing, only half the time will be available to them. Whether in terms of time slot or in terms of frequency, either you reduce the frequency band FDMA or you reduce the time slot. And as a result, what you see is that the sum rate means R1 plus R2. The total rate achieved by the two users put together, in the first case is log 2 rho mod h2 square, in the second case it is multiplied by a factor of half. So this important slide shows that NOMA is not only feasible, but NOMA provides a capacity advantage over orthogonal multiple access. How much we roll out in the standards depends on many more things. How complicated it is, right? Whether it makes it very expensive. Those are the things that are important. But again, we know that there is an option that is provided, and hence another very interesting example of NOMA. All of you are studying, doing projects on IoT and sensors and wireless sensor networks, so many things. So that provides a second example for NOMA. So what we do is that assume user 1 is an IoT device requiring only a low data rate, and user 2 is a demanding high data rate. This pretty often happens, right? Now if you do not use NOMA, you will have to give an orthogonal resource block for both of them. And if you give an orthogonal resource block to both of them, one of them is clearly used very inefficiently. somebody is needing it only once in a while, that also low data rate, and you are giving it an important chunk as time or frequency to that, which is equivalent to that somebody who is downloading videos. That is completely unfair, suboptimal, unengineering like. So what is the good case for this? Do NOMA. Give an frequency band to that IoT device, no problem, but allow the video device to work on the same band. So in this example, the spectral efficiency of OMA is poor since the IoT device is served with more bandwidth than is what it actually needs, while the broadband user is not assigned enough bandwidth. Right? I can see a lot of faces nodding, so that means you appreciate this part. On the other hand, the use of NOMA encourages spectrum sharing. Now that this point is made, we'll quickly take the last two slides. This slide is bringing the cognitive radio concept, right? Because you are reminded of this IoT device example that, okay, something like this we have studied earlier. What was that? Primary user, secondary user. Can I see nodding faces? Cognitive radio, right? So cognitive radio provides a good fertile ground, good context for the application of NOMA. Conventional power domain requires more power. So that means what it is trying to say is that power domain NOMA provides more power, but at the same time does not provide quality of service guarantee. QoS, right? In your networks course we are studying about QoS. And when I showed the key performance indicators, there also I was talking about that these are the key performance, and that means the quality of service, right? So quality of service means that guarantee that this much rate is available to me. Now that is not being done by power domain NOMA. So what you can do is you can use the cognitive radio concept, and whatever quality of service user is required, you can make it the primary user. It can be used as a special case. The CR NOMA, that means cognitive NOMA, can strictly guarantee the user's QoS requirements by using the fact that NOMA is a special case. It can be viewed as a special case of CR networks. This is the same figure as before. So here what we are saying is we are repeating the same example. This figure is, except there it was at the bottom, here it is at the top. Otherwise the figure is same. So here we are saying that user 1, that is a far off user which has got more power, we can view that as a primary user in a CR network, and the secondary user can be taken to be a secondary user. So that means it will do an overlay on the primary user. It will send on the same spectrum without disturbing the QoS of user 1, because user 1 is a primary user. Spectral efficiency is low since user 1 has a poor connection. Use of NOMA is equivalent to the application of cognitive radio concept. Okay. So this shows the example. Now the question is, does NOMA make sense only when there are two users? What to do with more than two users? On one hand, we are talking of massive machine type communication. We are talking of high connection densities, and on the other hand, we are talking of something that is so crude, so elementary. That is not true. How it is not true? This last slide shows that. So what this slide will essentially show it, I will roll it down very quickly. It shows that when you are given a large number of users, right, NOMA can be very easily implemented. The same NOMA that we have seen just now can be very easily implemented. You just have to do a proper pairing. If there are 100 users, do proper pairing. Which user will pair with which user? You can easily bring it down to 50 users, 50 resource blocks. If you don't use NOMA, for 100 users, you need 100 orthogonal resource blocks. If you use the pairing, you will need only 50 resource blocks. And this pairing should ideally be done in a manner so that the pairs have widely varying channel conditions. The more the pairing can be done in a fashion that the power conditions on the channel of the two users are widely varying, it can be shown that the capacity advantage is even more.
In the worst case, if the pairing is done between channels which are of similar strength, then it reduces to the same capacity as orthogonal multiple access. So this is the idea here. So consider a downlink communicating with one base station and m single antenna users. All the users share the same bandwidth resources to such as time slots, spreading codes, and subcarrier channels. Without loss of generality, assume that the users' channels have been ordered. Some channel will be strongest, some channel will be weakest. We can always do the ordering, H1 to HM. Consider the situation in which the nth user and the nth user are paired to perform NOMA. The insights obtained for the case of two selected users can be used for the design of dynamic user pairing approaches, because users are mobile, so these pairs may have to be changed dynamically, but the advantage will always be there and NOMA can be applied. So this brings us to the end of this. Thank you.
Questions, please. And more questions are expected from electronics people.
First from non-electronics.
Yeah. So non-electronics first.
So I'm non-electronic person.
Good.
So my
Which
question
department?
is, my question is, you
No,
were
which department you are from?
from
Which-
electrical engineering.
Oh, no, that is.
I want to ask technical question.
Okay.
Yeah. Sir, you, as I can see from your profile, you served as a member of 2008 Spectrum Allocation Committee. How would you rate it? I mean, is it a success or, I mean, the
I got the question.
scenario which
Yeah,
failed?
see, I'll tell you something interesting. Innovation in technology, innovation in service providing. One thing that we hardly ever talk about is the innovation in regulation. I have heard about TRAI, Telecom Regulatory Authority of India. Right? If TRAI would not have moved ahead with the times, we would not have seen a mobile phone in everybody's pocket. Because it has to come up with regulation which brings more players into the market. More the players, more is the competition. More is the competition, lesser is the price. Lesser is the price, more is the volume. More is the volume, price comes down further. So India has actually innovated in regulation, including that committee that you are referring to. The revolution that has happened, we don't give credit to those committees or those regulations, but they deserve a lot of credit. Because the prices at which India is getting mobile phones, or the kind of cellular auctions, spectrum auctions that are done in India, they are all unique. Every country does it as per its requirements, financial, social, all these things. India also had to do it uniquely. If you just want to borrow something from outside, it doesn't work. So lot of credit goes to the governments and the regulatory agencies for being very open-minded and very receptive to new ideas, and also willing to take a course which is unique in the world. If they don't have that courage, we will not be able to serve our country the way we are able to serve. Yeah, please. Localization-based services are increasing, right? There is absolutely no doubt about it. The more increase in the demand for localization services, the more precise localization will be available. But at the same time, it also has some implications for the privacy, right? And also for law enforcement agencies.
And this will be actually, machine learning is going to play a crucial role in the future.
So that's what I'm coming to. So many of these questions are not technology-based questions. They are more like society, behavior of society, what is the law of the land, what is the price at which cost will be available. So naturally, the more good localization, the more users will demand for it, the better services will be available.
While in 5G communication, we have to use the directional waveform.
Right.
In that case, if a precise location is going to be...
No, that will not be a problem. See, that will not be known to the user or agencies. That in any case will be done because of massive MIMO. Massive MIMO means that even though we are operating in a wireless domain, by using multiple antennas, we can steer the beam exactly in one direction that we want, using millimeter wave or using massive MIMO combination. And because we can steer the beam, so we can avoid both interference and at the same time provide as if it is line of sight. So that physical layer will do, but that will not come at the top layers. For it to be used for localization services is an entirely different thing.
So electrical, computer and any other department.
Yeah, please.
सर मेरे को एक कंफ्यूजन थी उस टाइम पे थी कि हम जो इसमें लेते हैं मतलब फ्रीक्वेंसी सेम होती है और टाइम भी सेम होता है, तो हम जब उसका पीएचडी बनाते हैं किसी सिग्नल का, तो हम उसमें पावर फ्रीक्वेंसी के बेस पे देखते हैं कि कौन सी फ्रीक्वेंसी पे कितनी पावर आ रही है, उसकी बेस पे हम डिवाइड करते हैं कि मतलब हम अलग अलग सिग्नल को डिवाइड कर पाते हैं फ्रीक्वेंसी के बेस पे। सर सिंस यहाँ पर हम सेम फ्रीक्वेंसी ले रहे हैं, मतलब कि दोनों प्राइमरी और सेकेंडरी यूजर सेम ही कैरेक्टर फ्रीक्वेंसी पे मोल्डेड हुए होंगे,
Correct.
तो सर अगर हम मतलब हम ये कैसे बता सकते हैं कि प्राइमरी यूजर को ज्यादा पावर जा रही है और सेकेंडरी यूजर को कम पावर मिल रही है, मतलब उन दोनों की पावर तो सर ऐड हो जाएगी ना, तो उनका पीएचडी निकालेंगे हम,
Correct.
तो उनको सर डिफरेंशिएट कैसे करेंगे कौन सा सिग्नल हमारा प्राइमरी यूजर के लिए था और कौन सा सेकेंडरी के लिए?
Correct. Very good. So if you study, for example, code division multiple access, if you are using two distinct codes, even in a composite signal, it's very easy to bring out the two signals. Because what happens, I'm just giving one example, there are multiple ways of doing it. I'm just giving one example, that if the two codes are orthogonal, what happens is when the code of one user is multiplied by the code of other user, that user gets nulled out. So what is left is remaining only the main code. So it is not as difficult a problem as it appears. It can be done either ways.
So that is code domain normal, sir.
No, it is code domain NOMA, but that it is not necessary that it cannot be used here.
My confusion is power domain normal.
No, even in power domain NOMA you can use it. So it doesn't mean that you cannot use code domain in power domain.
Thank you.
Any other question? Okay then, thank you. Say about the lecture is that many faculty and students alike were apprehensive about the topic, thinking that it is a electronics related topic. So what would be there for them? But now I am sure that all the apprehensions do not stand, and all of us are now more informed about these G's and 5Gs in particular. So thank you, Professor Chaturvedi, for such an enlightening and insightful lecture. I am sure the audience are greatly benefited by the insights on the topic. So now I request Director sir to please present a moment to the public.
This is stand.
Acha.
You can read it.
Okay. We have thought about it, how to keep it also.
Thank you, sir. I request guests to please. No activity is complete without grateful to all those who had contributed towards the success of the activity. To this end, I am privileged to present a vote of thanks to all of those who have been involved directly or indirectly in making this lecture a success. Specifically, I would like to thank Professor Chaturvedi for sparing valuable time and from his busy schedule and for such a wonderful lecture. We are thankful to Professor Padi for providing moral, administrative and financial support for this. My sincere thanks are due to the faculty and students for being eager and for patient learning. It is difficult to organize such an event without the support of students. This lecture is no exception to that. To name a few, I am thankful to Jitesh Sharma, my PhD student, Himanshu Meena and Bhupat Singh who have worked hard to make this event a success. Thank you all again. Jai Hind. We'll be there in the conference room. Directors, yeah. Again.
So I thought we will utilize this opportunity to have an interactive session because you get 1% in 1 million, and that is still in a lower side. And how we can manage both academics and administration parallel. And that is what actually you to learn over.
Good evening, sir. Myself, my name is Bharat. I have more introductions like that. Myself, Professor H.P. Tiwari, Electrical Engineering Department.
Himanshu Chaudhary, Professor and Head Mechanical Engineering. Dr. Manish Vashi, Head Chemical Engineering.
And Deepthi Sharma, Head Department of Humanities and Social Sciences.
I'm Sujit George, I'm Associate Dean, Dynamics Department.
Amartya Chaudhary, Center for Energy and Development.
Sir, I'm Professor in Chemical Engineering and I'm Dean Faculty Design.
Bhagwati Sharma, I'm from Material Research Center.
Vijesh Gopnani, Head CSE Department, Computer Science.
Mushka Singh, myself Jyoti Joshi, I'm Head Department of Chemistry.
I'm Kanupriya Sachdev, I'm Professor in Department of Physics and Material Research Center, and I'm heading Department of Physics right now.
Rakesh Jain, I'm Professor in Mechanical Engineering, also Dean International Affairs and Alumni.
Okay.
Professor Mahesh Kumar Jat, I'm Professor in Civil Engineering Department, presently working as a Dean in Student Welfare.
I'm Sanjay Mathur, Professor in Civil Engineering and Dean Planning and Development.
Sir, I am Ramesh Prabhu from CSC Department. On behalf of Professor Vijay Lakshmi, Dean DIS, yes.
Which team?
Dean DIS, Digital Infrastructure.
Okay, digital.
Sir, Deepak Verma, I am representing Department of Management Studies.
Sir, Dr. Daniel Pili, Computer Science Department, representing Associate, I am Associate Dean Research, representing Dean Research.
And I think, and in particular, Professor Padi, he invited me to spend some time with all of you here. We are also meeting here to discuss about general things about how an academic institution is different from, for example, a government institution or a government ministry. Although we are primarily using government funds, but those are public funds. So we say public funds mean that they are funds that are collected from the citizens of the country, from the taxpayers. And so we are responsible to every stakeholder in the country. Even the person traveling on the road outside, he has a question to ask MNIT, why this is happening, what is happening. That sense of responsibility that there is nobody to whom I am not answerable. I am answerable to everybody. If that feeling all of us can develop, it is one of the most important cornerstones in building a very vibrant, very responsive, a very loved academic institution. Because as a natural corollary, you will be answerable to your students also. You will be answerable to your colleagues also. It is not that only the director can ask questions, anybody can ask questions. Because we are publicly funded. At the same time, there is a very important reason why IITs and NITs, they were conceived and structured through acts of parliament. They were not built by a cabinet notification that MNIT Jaipur, today the cabinet has decided that we will create MNIT Jaipur. Why is that? That this is the way it has not happened. You have a NITSER Act. You are governed by the NITSER Act, NIT Act. And that act is not by the cabinet, it is by the parliament. So we are answerable to the parliament. And we should not think or behave as if we are department of a government. We are not thinking like we are a ministry. What does it mean when I say we should not think or behave like a department of a government? What it means essentially is that
we should be more merit oriented rather than seniority oriented. We should do things which bring academics to the center focus. If a student is meritorious or if a faculty is meritorious, which year he or she is from, which gender he belongs to, which category he belongs to, which administrative position he or she belongs to, has no relevance. It's irrelevant. So how do we bring meritocracy at the center? And in particular, how do we bring academics and research to the center? By letting everything else go into the background. Simple things. But what has happened is that over a period of time, for a variety of reasons, which are not necessary to be discussed or debated at this stage, many of our academic institutions have suffered for very simple reasons. Another way to put it is that an academic institution is not built of brick and mortar. It is built by the people, faculty and students. Tomorrow if the government grant is cut, we will still survive. Right? But if the culture goes down, if academics is not given privacy, any amount of budget is not going to help. Any amount of building is not going to help. It's good about it. The alumni feel good about it. Because their own prestige and perception in their society goes up. Arey, he's from MNIT Jaipur. That's a wonderful issue. And because these are very involved and complicated exercises, many times we think that we are a drop in the ocean. हमारे करने से क्या होगा? इतना बड़ा इंस्टीट्यूट है, so many faculty are there. ये नहीं करता, वो ये नहीं करता. हम क्या कर सकते हैं? बस इतना ही देखना है. इतनी बड़ी बड़ी बातें क्यों करनी कि वो क्यों नहीं कर सकता है? छोटी बातें करनी है. This is true for every institute. I'm not saying anything specifically for MNIT Jaipur because मैं उतना अच्छा well versed नहीं हूँ. Although I have been here. I've been here and I was happy to know that somebody also remembered that I was here earlier. So, in fact, we sometimes feel that we should design some kind of a program for academic leaders. These are not leaders, right? Those who are heads may tomorrow become deans, may become tomorrow director, right? Associate dean, whatever it is, something to make a change, to make a mark. See, for example, one very elementary, if I may say, many of us don't seize the opportunity. I'll give you an elementary example, which is true for IITs and IITs, large number of them. The head's position. The head sometimes perceives that the position is as if he or she has to take the department's view to the institute and the institute's view to the department. That is my role. This is just like a postman. You are not a postman between the institute and the department. You are a leader. You can influence the institute the way to think. You can influence your colleagues the way to think. This doesn't mean that you have to overrule whatever the colleagues are saying or whatever the institute is saying. No, only I am right, you are wrong. And steer the thinking in the direction you want with good preparation. Needs hard work. If you think and nobody better than you knows what your department is lacking. One thing is of course resources. Right? That you can discuss with the director or right. But there are so many things that are not dependent on resources. During your tenure, can you make a change there? Can you make a difference there? In your department, every department is unique. In every IIT, in every NIT, every department is unique. Even in the best of IITs, every department is not good. Even in the worst of academic institutions, every department is not bad. Same with students. The brightest students get to us. India is a country which values education. As a civilization, we have always treated education very highly. So there is no dearth of good students even in private institutions. Very bright students. Forget IITs and ITs. They of course get the cream. I mean, in a country of 140 crore, do you think only these 50, 60 students are bright? We have at least 5 lakh bright students every year. It is a pity that we are not able to capitalize on their preparation and on their academic brilliance to be able to give them the education. So can you work on your own department? Same thing for deanship. Can you work in your own deanship? That okay, this is what my institute needs. Fortunately, I have got this opportunity. Thanks to the director, I have got this opportunity. Now I'll make the most of it. 10 years down the line, people are going to remember that how much hard work I could do. And hard work means getting to find out what is the situation, getting to know the thoughts of people, hearing as many people as you can talk to, getting to know the views of everybody, not thinking that you are the wisest person around. Just because you become head or dean, that doesn't mean suddenly you are the wisest person in the department or in the institute. Same, when I was the director of IT, I used to tell them every time, I am not the wisest person. Right? But that is true that the buck stops many times with the director. So if somebody has to ask, they will ask the director, why this happened, why did it? So the director has a very difficult position. I'm sure you appreciate that position, just like you have a difficult position in the department. So many people are very happy to support the head or the dean or the director, and rightly so, because they realize the vulnerability or the softness of that position, that how vulnerable the position is, because of which all kinds of pulls, pressures and those things come. But you should not start doing the work of the director. Oh, because he will be under pressure, so let me not do this. No, you do your work. It is his job to take the pressure, ना? अगर सारे लोग ही प्रेशर में आ जाएंगे तो फिर इंस्टीट्यूट नुकसान में आ जाएगा. If you need something, if you want some change, go and do it. That has many ways of deflecting the pressure. Many ways. अरे क्या करें, वो सुनते ही नहीं है. डॉक्टर कहते हैं खत्म हो गया. डॉक्टर खुद चाहते हैं कि वो चेंज हो. Right? So don't do the job of the director. Let the director do his job. You do your job. Your tenure is not infinite. खत्म हो जाएगा कल परसों next day. So none of these leadership positions are file pushing opportunities. वो आधे घंटे जाएंगे चाय पिएंगे साइन करके आ जाएंगे, वो नहीं. वो तो उसके लिए तो असिस्टेंट रजिस्ट्रार है, उसके लिए तो सुपरिटेंडेंट ऑफिस सुपरिटेंडेंट है. लीडरशिप पोजीशन, क्या नया करना है, क्या अच्छा नहीं हो रहा उसको कैसे करना है, उसको स्पॉट कैसे करें, उसको कैसे स्ट्रेंथ कैसे लाए. आई एम श्योर मेनी गुड डिपार्टमेंट्स इन NITs are either competing or better than some departments in IITs. Can you identify which departments you are closest to, say in an IIT? Maybe chemistry, maybe electrical engineering, maybe physics, maybe humanities. Can you aspire to become like that? If you are already there, can you aspire to see, okay, which is the best department in the US? Can I become like that? What are departments? Culture क्या है, practice क्या है? यही तो डिपार्टमेंट होता है. अच्छी प्रैक्टिस, अच्छे कल्चर. You have to create a culture and practice so that the best students and best faculty come to you. In terms of goal जो है बस वही है, simple goal. कोई डिसीजन आता है ना, डायलेमा, मेरी टाइम से फेसिंग डायलेमा, इसमें क्या डिसाइड करें. आप सोचो कि हमारी रेपुटेशन पे क्या असर पड़ेगा इससे. अभी one elementary mistake that many of us do, we forget that ये जो students हमारे यहाँ आते हैं, they are here for a brief period, but they carry those impressions of the brief period for the next 40-50 years. अगर उनके मन में रिस्पेक्ट नहीं है, अगर उनके मन में केवल डर है, तो वो कहीं ना कहीं आपकी रेपुटेशन को इफेक्ट करेगा. Can I generate something like this that when they graduate, they go with a respect for the department, the respect for the institute, not a fear for the department, not a fear for the institute. Respect के मतलब लव तो अपने आप आ जाता है, क्योंकि 4 साल रहे हैं, impressionable age में हैं, So alumni will automatically start associating themselves. But many alumni across the educational system, if you probe them deeper, they are not respecting their alma mater. Because they didn't have fair experiences, they thought that the system was unfair, they thought that the curriculum was something could have been better, they thought the practical was better, whatever, different ways. So अगर वो हम टैलेंट बना लें कि ये जो ब्रांड एम्बेसडर जा रहा है हमारा, क्योंकि उसके तो जीन में आ गया, उसके परमानेंटली लिख दिया MNIT जयपुर, he cannot erase it, वो कभी भी उसको साफ नहीं कर सकता। वो ब्रांड एम्बेसडर हमारा टारगेट हो जाए तो हमारे बहुत सारी चीजें अच्छे से हो जाए। And don't get the impression that by being soft or by giving good grades you generate respect. No. You do not generate respect by giving good grades or by being soft or by being unnecessarily courteous or by making him happy. No, not at all. You generate respect by doing hard work, by showing that you are fair, showing that you are treating him or her like your own child. Very simple. These are the simple things. I think I should not talk that long. आप लोग कुछ बोलना है?
Just actually,
आप लोग कुछ बोलिए.
Most of the heads actually being, kind of appointed actually the first 3 or 4 months back. And the general consensus was, NITs are director-centric. Like without director, nothing can happen. So, which is for some extent true, because in IIT system, probably we had a dean finance, we had a dean administrator, but here actually there is no dean finance.
Okay.
So everything has to go through director, and the budget whichever available to you, like you have to take permission to the director and spend it. So then I told all my heads of the departments as well as deans that whatever the money available to me, you distribute and take it. Let me not keep any penny with me, but you try to spend it. Now the month is January. Now they all are in pressure how to spend that. So at least जो director साहब उसको approve नहीं कर रहे, वो चीज़ नहीं रहा. I said you took the money, but I had created a couple of constraints, saying that you cannot buy, furniture, air conditioners. It has to be spent only on equipment and undergraduate education. I think they tried hard, and now they are almost kind of, that ownership and the leadership, what you say. So they all own 2 crore rupees to run their department now. So I think this is one kind of decentralized जिसको कहते हैं.
Yes, very good. The more you empower the lower levels, but the head should do it in the department also.
Yeah.
The delegation should not stop.
Anyway, so what was the picture? You can ask anything.
Please.
पहला तो यही था जो आपने बोल दिया that NITs specifically are very director centric, and the things which used to be a norm 3 months back, now they are no more in place. So again you have to reorient the whole system.
कुछ लोग सिस्टम में हमेशा से रहते हैं, राइट? उसी क्यों चिंता करते हैं? So if they become our role models, तो हम लोग क्या है? वो हमारे रोल मॉडल हैं।
रोल मॉडल नहीं है, पर वो हमेशा रहते हैं।
मैं वही कह रहा हूँ, कुछ चिंता ही नहीं करें। वो तो हो सकता है 10 साल बाद में है, क्योंकि they are not moving ahead with the times and with the system. आप सिस्टम को आगे दौड़ाइए, जितना घोड़ा आगे दौड़ेगा पीछे ये लोग भी साथ में आ जाएंगे या they will follow all part. Run faster and faster, more people will be with you than with them. तो मुझे तो लगता है कि we are here, and I fully agree with you that we cannot change the culture overnight, but this sentence is not an excuse not to change the culture.
वो होता है ये है ना सर, जैसे somebody comes with a vision, and like sir has empowered us all with, but before that it was not there. So whether this culture will continue once he is not there,
तो क्यों चिंता करनी, कल किसने देखा?
नहीं देखा, उससे कल्चर वापस उल्टा चल जाता है।
तो आ जाएगा, लेकिन see chances नहीं आएगा, इसलिए नहीं आएगा क्योंकि what happens is the more stronger system becomes, the more it becomes strategically dependent. Right? एक बारी ingrained हो गया ना, जो भी नया डायरेक्टर आएगा, वो सब कुछ CEO ने कुछ किया भी, तो आप खुद ही चार लोग जाके बात करेंगे, आप एक बार सोचिए। And as I said in the very beginning, we are publicly funded institutes. NIT Jaipur किसी की भी प्रॉपर्टी नहीं है। आपकी ना हमारी ना बोर्ड की ना चेयरमैन किसी की नहीं, सबकी है। So anybody to everybody can go and talk to the director. Bad things हटाने में जो है वो क्या कहते हैं उससे वो जल्दी आ जाती है वो मतलब to slide down is easier than to talk. But अगर आप थोड़ा ऊपर चढ़ेंगे ना तो बहुत मुश्किल है करना। और अगर कुछ होगा तो देखा जाएगा। It is not something that you think that effort will go waste. This effort will never go waste. It will be a positive contribution. It may be one more block in the evolutionary journey of MNIT Jaipur, right? उसके evolution में होगा और उसमें कभी-कभी back and forth भी होता है। वो डायरेक्टर चाहे वही भी रहे, वो भी सीखता है, वो भी कभी-कभी changes करता है। जो उसने पहले साल में किया सेकंड ईयर में कुछ और करता है, थर्ड ईयर में कुछ और करता है, क्योंकि वो फीडबैक मिलता रहता है। फैकल्टी आके मिलती है, डीन मिलते हैं, हेड मिलते हैं। तो ये कोई जरूरी नहीं है कि आप डायरेक्टर से कहेंगे नहीं आपने 5 साल पहले ये किया था आज भी यही कीजिए। क्यों करे भाई, आज तो MNIT Jaipur बदल गया है, तो आज भी बदलेंगे। क्यों करे भाई, क्योंकि फीडबैक किया है, हमने कोई पॉलिसी चलाई, वो पॉलिसी का फीडबैक कितने मिलेगा उसको फाइन ट्यून करेंगे। सो चेंज तो ये तो महात्मा गांधी ने भी कहा है कि वो कहते थे ना वो अरे आपके डबल स्टैंडर्ड्स हैं, आज जो पहले कुछ कहते हो आप कुछ और कह रहे हो। ये जमाना मतलब more water has flown, more facts have come to light, more experience have happened. So naturally change will happen. How can you say कि change नहीं होगा? जो हो गया सो हो गया, इसका मतलब आप you are not a living entity.
Stagnant.
हाँ stagnant हो गया तो।
So आपने बोला था महात्मा गांधी ने भाषण की be the change you want to see in the world.
Right.
That is the you have to start the change from yourself.
देखो लीडरशिप अपॉर्चुनिटी बहुत ही यूजफुल अपॉर्चुनिटी, बिल्कुल इसे कहते हैं गॉड सेंड अपॉर्चुनिटी।
Interaction and you can say coordination between teaching and non-teaching. And so here in our case, like sometimes our system is older and the result coming, so that learner will be really find sometimes many difficulties to implement that. So probably we are finding ways to how to deal with those situations. Because they are not sharing that same vision with us, like everybody is in the faculty, because they will be having more horizon and experience rather than. But we are getting pushed back from every corner of that aspect.
Correct.
And administrative functions, faculty is like temporary jobs also, and they are permanent like. So that's like how we can.
इसमें एक सब्जेक्ट होता है आपके किसी कोई मैनेजमेंट के भी है, राइट राइट, देयर इज समथिंग कॉल्ड चेंज मैनेजमेंट, राइट। सो वो जो भी आप चेंज कर रहे हो आप इंस्टीट्यूट में और उसके बारे में कर रहे हैं, सो उसमें कई बार क्या होता है यू थिंक अहेड, यू कैन मेक प्रोविजंस इन द चेंज सो दैट द पीपल हु आर लाइकली टू पुट रेजिस्टेंस उनके लिए कोई एग्जिट रूट है। मतलब वो स्पेसिफिक आंसर मैं तभी दे पाऊंगा when we go deeper into what the problem is, which we should not do here. I think we should not get into specifics here. But what I'm saying is, it needs a little more strategy and planning. The kind of thing that you are saying.
Yes, sir. It's like for example, let us say everybody is like everybody is facing difficulties in purchases, procurement, everywhere. Like, things are not moving at speed what one is expecting or what we are expecting.
तो उसमें जो भी आपका ऑफिस है परचेज का, प्रोक्योरमेंट का, उनका एक सेशन होना चाहिए डील्स के साथ, हेड्स के साथ।
स्टोर सेक्शन, but they were very lethargic almost for last decades. It was a very small and you have to visit their office only then file will go.
उनका कोई डील है?
उनका कोई डील नहीं है।
हाँ कोई डील है।
Very good suggestion. Very good.
So actually, what I feel is that there is a confusion or conflict type of thing. In model A, we say that this is the right thing to do,
See, first let me answer it more precisely, then I'll tell you a slight joke. So, आपका कोई परचेज रूल होगा, कोई किताब है? देखिए, अगर केवल GFR है तो बोर्ड में जाकर उसको चेंज करा दीजिए। नहीं ऐसा नहीं है, let me start with the first thing. आपको क्या कहा था कि आपको ऑटोनॉमस बॉडी पार्लियामेंट से क्यों बनाया गया है? The government and the society do not want you to behave like a government department. तब तो वो ऑटोनॉमस नहीं बनाते ना। तब तो आपकी फाइल जॉइंट सेक्रेटरी के पास जाती, आपकी फाइल जॉइंट सेक्रेटरी के पास क्यों नहीं जाती है? नहीं जाती है। By design, ये कोई ओवरसाइट नहीं है, ये किसी की गलती नहीं है, ये मिस्टेक नहीं है, ये डिजाइन है। इसीलिए आपका बोर्ड बनाया गया है। आपको जो डिफिकल्टी हो बोर्ड आपको सॉल्व करेगा। अब अगर मुझे नहीं पता निट्सर एक्ट में क्या लिखा है, निट्सर एक्ट में कोई कॉम्प्लिकेशन है तो आई डोंट नो, बट ये जरूर है कि जो वेरी ब्रॉड GFR के प्रिंसिपल्स होते हैं बिल्कुल फॉलो करनी चाहिए, 100% फॉलो करनी चाहिए, बट उसको हम कस्टमाइज कर सकते हैं अपनी नीड्स के हिसाब से। हाँ, हाँ, अगर परमिटेड है तो आप वोट कर देगा।
सर स्पेशली मेरी मीडिया क्लास सर
नहीं, मैं वही कह रहा हूँ, भारत क्लास के बारे में मैं बात वो नहीं कर सकते, लेकिन उसको कैसे वेव ऑफ करें या उसका प्रोसेस क्या होना चाहिए या कॉम्पिटेंट अथॉरिटी कौन है उसके लिए, वो डिफाइन किया है।
For the academic institutes, the GFR cannot fit the bill. For example, if I have to purchase the equipment for my laboratory, then it will have something specific. I have to go by the brand name. I have to go with the specific specifications. For the GFR or GM, whatever are the government system, they doesn't allow. So that has to be. So, by the way, something very right.
मेरे ख्याल से आप NIT सिस्टम के आप NIT लीजिए, NIT वाराणसी का मन होगा कि आपके क्या पसंद है?
सब ऐसे ही परेशान होते हैं।
नहीं हो सकता है, नहीं हो रहा। एक बार बता दो, एक बार बता दो, और नहीं तो फिर तो बहुत अच्छा है। अगर सब परेशान हो रहे हैं तब तो मिनिस्ट्री के पास जाके भाई बोर्ड से ये पास करना है।
So actually, उसमें the challenge is that the ministry at time to time they release some poems which are not actually authors, but most of the institutes, I think almost all NITs, they treat it as an author without application of their own intelligence or that is the biggest struggle.
I think it's the legacy, the system. We came from RSC system to the right.
जब NITs बनाए गए थे, at that time it was very loudly and clearly written that you have to follow the rules and regulations and practices of your IIT of the region. तो जो मेंटर IIT था उसके rules regulations अगर लेते तो ये सब चीजें नहीं आती। हम
वो अभी भी ले सकते हैं, वो अभी निकाल लीजिए, फिर लिखा होगा, अभी भी ले सकते हैं।
हाँ। So वो depending upon the director. When we had a director from IIT Delhi, we were following that. Then we had a director with background of IIT Kanpur, we were following that.
ये मेंटर IIT तो एक ही होगा ना?
Delhi है ना? Delhi है पर अब तो सर 20 साल बाद तो मेंटर IIT तो मेंटर IIT आगे उसके बाद
और मैं सर हमें ऐप को देखना पड़ेगा।
नहीं, आप देख लीजिए, आप बिल्कुल देख लीजिए, बट ये मैं कहना चाहता हूँ कि sometimes some of us actually do not want to spend. वो मैं बता रहा हूँ, क्या होता है उसमें कि हम जो है जिम्मेदारी नहीं लेना चाहते, उससे जो है बचना है। आप जिम्मेदारी लीजिए, जिम्मेदारी नहीं लेंगे तो फिर आप you cannot have the cake and eat it. लीडरशिप पोजीशंस का एक बहुत बेसिक रिक्वायरमेंट है, लर्न टू टेक रिस्पांसिबिलिटी. इफ इट इज an honest mistake, nobody will ever penalize you. Of course, if you are playing games, if you are doing mischief, system will catch up with you. By and large, faculties type routine. We cannot think like that. We cannot think like that. क्यों चिंता करनी है? ज़्यादा दिमाग क्यों लगाना है? मतलब good faith make advice, I can tell you from my experience. See, please put yourself in the shoes of the ministry. Right? आप अगर खुद ही जॉइंट सेक्रेटरी होते हैं, एडिशनल सेक्रेटरी होते हैं, सेक्रेटरी होते हैं, आप सोचते हैं तो उनसे आज ही मत पूछा I'm telling you good faith. आप पूछ रहे हैं इसका मतलब आप जिम्मेदारी नहीं लेना चाहते हैं। जिम्मेदारी लीजिए ना आप।
सर एक्चुअली
गुड फेथ पे कर रहे हैं ना
आप
आप।
जो वो मान रहे हैं ना उसका रीजन ही आई डोंट वांट
कि भाई दे आर नॉट एन ऑटोनॉमस बॉडी ना। आप समझिए ना।
ये काम हम कर रहे हैं।
हाँ नहीं उनसे आप आज ही पूछिए नहीं मैं ये कह रहा हूँ। और चूंकि आपके बोर्ड में गवर्नमेंट नॉमिनीज का एक होते हैं तो प्लस आपके बोर्ड में प्रॉब्लम है मतलब जनरल एनआईटी बोर्ड होती है बट these problems are very very solvable. It's not they're not very difficult to solve. And in general the culture of what is in the interest of the institute अगर डेवलप हो जाएगा तो लोग जिम्मेदारी भी ज़्यादा लेंगे। ये प्रॉब्लम्स अपने आप चली जाएंगे लोग साइन भी करेंगे ज़्यादा। कहीं कहीं वो भी एक हर्डल है।
Actually, the very intellectual, simple example. What has happened is one non-teaching staff, they said that we are going to organize a dharna because our promotion was not there. And you will surprise ignorantly and few officers, they have recommended forwarded. Because in the past actually heads and deans they were fully forwarding, not giving their comments. So I said you have to read and you have to strongly put your comment. So with that practice they have recommended this also. So what happens actually, I think things are changing, no doubt about it. Only that store issue also most of the things have been solved. Those काफी solved हो गया. और department की ऐसी चीज भी है ना, हम लोग actually professors normally we are not very good at rules. Sometimes, not always. अभी सब लोग सीख लिए करेंगे, how to handle independently, and things have improved very significantly. I think the second joke part we haven't heard.
Sorry, मैं तो भूल ही गया. What was that?
There are two models. That one that I will not get into the bureaucratic formalities and go ahead.
Purchase को लेकर.
अच्छा मैं भूल गया. नहीं मुझे याद नहीं आ रहा. मैंने क्लास में अभी याद आएगा तुम्हें.
Any other questions?
Sir, it could be because I am a student of this institute, so it could be a long thinking. I have a feeling that when we were at REC, academically we were very strong. But now since becoming an NIT, because of our promotion rules and all, there is a lot of emphasis on research also. So somehow the two don't seem to have reconciled. In my mind, the academics seems to have taken a kind of backseat, and especially with the new faculty which has been recruited, I am not blaming them because the promotion rule says so. So one will do whatever is there. So in IIT, how do you reconcile the two? That the research should also go on, but simultaneously academics does not suffer. So this was one question. Second was, say earlier a lot of us went under QIP to IIT. And that exposure, I think, changed us quite a lot. Now that is no longer there because PhDs, we recruit PhDs only. So can there be a institutionalized mechanism for interchange of faculty, say, going to IIT and like that? Currently there is no such mechanism in place. My feeling is that really causes a lot of change in a person once he gets exposed there even for 6 months or a year.
आराम से किसी IIT के साथ कर सकते हैं.
So that becomes one-to-one IIT because since IITs are like a consortium, can we have something like a consortium?
The panel person will be signing an MOU with IIT Delhi. As per the Act, actually the nearest IIT. So we had option of Jodhpur and IIT Delhi. So we have gone with IIT Delhi. And probably there are two things. Suddenly in one of the meetings, exactly what Professor Chaturvedi said, I requested a common forum to ministry that our professors and deans also need a leap type program that you have done for IIT professors, most of them. So our young professors of NIT also should need to be trained. So they said, okay, good, you go ahead with IIT Delhi and try to have a joint program where at least you can take the responsibility of training your own people and another 2-3 nearby NITs like NIT Kurkhetra, NIT Delhi, NIT Uttarakhand and NIT Jaipur. These 4 institutions can be trained by 2 older IITs and a couple of actually NITs. So I think there are a couple of things. I think there are FBP and other activity, exposure to IIT structure, but completely spanning for 6 months to 1 year is certainly difficult to ask because of loading and other things. But a frequent visit is certainly possible. A joint proposal of research is also possible. And that is always open. Yeah.
I think first part of the question is very important. See,
What is that seeing a practice?
I think that was both on. So what I'm trying to say is that some people feel that investment made in teaching is unproductive because it does not get reflected in my CV and so it will not play a role in my promotion or career progression. But actually that is not true because if you do effort in teaching, there is a very high probability that your research will also improve because your understanding improves, because you are giving more weightage to the students and you are giving respect to the students' queries. So that means you are preparing for it more. So the chances of you being able to conceive good problems or solve good problems, the level of your research, the impact of your research, all these things can possibly be good. Second thing is that students are very discerning. If you put in effort to prepare for your class, you develop a good reputation. If you develop a good reputation, you get good students also. Right? Time today.